I'm going to go over the topic of phase shift with sinusoidal functions and hopefully help you understand how to find a shift or a transform that has a phase shift. You're given a function graph, or maybe you're given a phase shift construct a function that's a specific shift. We did into this, it's been ages, but it was March 11th to the 13th, your last 3 normal-ish days before school was closed. So if you look back to some memories, 8/22, 23, 24 started to get into this. So we do know some things together left. And we saw is maybe Thursday over notes like this. And I'm going to put this in front of you again to having that layered here, that layered look on the inside of the function, sine or cosine. Having that b value out of is going to be important. So a lot of time notice on problems in other places they will kind of give you function out the inner fact. So something like I gotta calibrate this or something. Let me try that again. Okay. Sorry. So here equal. And it's like 4x. Instead of getting nice, separated like that. This example, thinking of this a week or two, but the audio failed. It was just choppy. So same, this is the same that I did video at the bad audio. So if you kind of follow, but you both this is a good one to watch of me. Okay. To the next page. Here we go. Zoom in just a little bit. Okay. So just like I discussed in the last page, when you have layer have the active look, okay, really be whether it's factored or not, you can see coefficient on the variable. In this case, is b. So what we want to do is factor b. That inside idea. Okay, so right. This that. Probably see that it affects these side. So when you go back to whatever b is. Okay, if I'm going to divide both this term and this term by b is, and that leaves us here. Divide. It's just the same value. Go here. Different. we factor that. We was discussing over somebody, and let's say we're the test function. Like we did here, the general in this should see when you to by value is also 0.5. You have that, so that's why it goes and 1. All right, great. Now we got our, we see our A here. For and finally, so B value you get the so 5 and here. See, I have just put this into the default mode of radians. We're doing here in resonance degree symbol for around where they sit and problem this in degrees. So so 5 we calculate here, which will help the graph with that formula. Okay. By and you want to do your work by same multiplying by for 1 is multiplication here. Factoring out the value, we can see shift by units. Right. Just make it easier to see. So, right. We have midline adjustment or vertical shift. So shift, vertical. Well, not paid. Now, see cosine function. I actually starting with here things. Or I talk about scale and my eyes are skewed towards the fourth quadrant. Graph first quadrant, all the positive counting happens. Radian still have amp 4. So if I scale, say 3 or 6, yeah, because we're oscillating above that to 4, the point would be a total of that negatives. So 4 units above 3 maximize the line in. And if you're doing this paper as you go through these, I would just like uh, it's just okay. So I know a function starts at the top of the tube, and then it goes through its bottoms out back to the, you know, that kind of general. The thing that makes this tough is shift. So let's do. Let's take that point that's normally y-axis and we're over this. So we'll only be on the y-axis phase for right point. Take that point, take over. Now, kind of each scale, but 4 more steps make full, to a full period of the graph. So after you top out, it's going to do -7. And back through them and back. That would be so that is like cosine. For right. So full credit on a graph like this. We've got our scale labeled vertical. We even have our horizontal. But this is where the period calculation really comes in handy. To get full credit, absolutely right on this one, we need to label our horizontal axis. So because I know one full period from this point to this point is 8 pi, and I know I've got 4 equal steps to make. That's an 8 days. Okay, so 8 pi, cut into 4 equal steps. That means each of those steps is 2 pi apart. So from pi plus 2 pi, that would put me at 3 pi. That's a 3, okay. And then 2 pi more, that's 5 pi. And you're just counting by steps of 2 pi, so 7 pi. And then the last one, plus 2 pi more, would put you at 9 pi. The only thing that bugs me about this graph is this, we said this is pi, but then I pretty much have the rest of these looking like they're the same length, even though they're 2 pi. So a picky person is going to put a little broken lightning bolt right there to show that your scale at the beginning isn't exactly, it's not a perfect increment. All right, so I think most people get away with that on paper with or without that symbol, but technically that does clean it up for you. Okay, so back to the beginning, it's really important to factor out that b value from the internal expression. And in general, if you could see, you got bx plus c, you could factor the b out of that constant that you have by just dividing it by the b value. Now, subtraction is what took us to the right. So it takes that anchor point from where it normally is and pulls it to the right. So I hope that clears it up a little bit, but it takes practice, and these are the tougher ones. So hang in there.